This is Bill Stone. I'm president and co-owner of TruTech Tools, and we're really pleased today to have Steve Pascuzzo from Testo, who's the manager of the commercial division. TruTech and Testo, our relationship goes back for a long time. I used to work there starting in 1999. So we have a long, rich history with Testo. I worked there for 10 years and then came to TruTech and been here since for the last 11 years. So we love the relationship we have, and Steve is new to me in the last few months, but he's got a great depth of experience. And TruTech Tools carries a lot of different products, test and measurement instruments, of course, the complete Testo brand, almost the complete Testo brand, most of the Testo brand, several other manufacturers, and a variety of test and measurement applications that include airflow, building performance, HVAC, and of course, indoor air quality or air quality, which is what we'll be talking about today. We've been growing terrifically the last few years. We've been winning Inc. 5000 awards. We're really pleased about that. And that the large credit is, I would say, due to our employees, our customers, and our vendors. We have a great participatory relationship. There's the team at TruTech. I think it might be missing one or two people because we've grown so much even during the pandemic. Next slide. This is just a view of our warehouse. It's usually this neat, actually. Matt and Bill Sutherland do a great job of keeping it in good shape. We have over 88 brands and thousands of products, and we're ready to ship 7 days a week now to try to get the products to you in the quickest fashion possible. We also have a free shipping threshold of only $49. So we're part of the equation here in helping our customers solve their problems, through education of what you need in terms of information and product and process from people like Steve. And then we fulfill on the process and product side and get you the right products in your hand. So with that, I'm going to turn it over to Steve to guide us through this topic today.
Bill, thanks a lot. Can everybody hear me okay? Or Bill, can you hear me fine?
Yeah, you sound great.
Okay, great. I'm going to skip past this mugshot, which I really don't enjoy looking at myself, but I'll have my contact information on the very last slide. But I came to Testo, actually, it'll be a year ago, just in a few weeks. January 6th, I think was my start date. Prior to that, I spent the last 6 years with Daikin North America. Daikin is a fairly recent entry into commercial VRV and VRF systems for large buildings, all the way down to high-end residential applications. I manage the Rocky Mountain states in the Southwest for them as an area manager on the commercial side. And prior to that, spent about a decade and a half with a company called Phoenix Controls Corporation. From when we were just a startup, I was employee number 5 with them, and then we were later bought out by Honeywell. But Phoenix still is pretty much a leader in the industry for laboratory variable air volume control systems, controlling critical variables like velocity and fume hoods, maintaining them to ASHRAE 110 standards, and controlling room pressurization and laboratory corridor pressurization, then tying that all back into integration to Siemens or Johnson Controls, whoever the building automation system vendor may be for that particular campus or building. And then before that, a few years right out of college with a company called LabConco Corporation at Kansas City, Missouri. And LabConco, still one of the big leaders in manufacturing and designing laminar flow biological safety cabinets for working on infectious diseases, chemical fume hoods, and BSL level 4 glove boxes. And before that, got my degree in my BS in pre-med biochemistry concentration, my master's in physics. And before that, I was goofing around in high school and college. So enough said about that. This slide, I kind of customized this a bit. The top row across the top kind of represents the majority of the environmental variables that we can measure at Testo, with up to as many as 30 different types of probes. And those probes and the associated instrumentation cover everything from HVAC applications on the facilities management side, uh, food sector, food sector covering both point of sale food applications whereby the health and safety of the patrons or the consumers of the food. Obviously, we need to have those food products tested for temperature and consistency. We've got probes for that. We're very large on the combustion analyzer side, both for automotive, which is how we really started back in Germany, back when we started out back in 1957, and combustion analyzers for here in the U.S. for the commercial industry for both power plant and residential applications. And we've got a whole division that you typically don't see on products that are being sold to the life science and biopharma and health marketplace for data logging of critical, again, measurable environmental variables such as temperature, pressure, relative humidity, light level, illumination level, UV radiation, and all that stuff has to be monitored and data logged on a consistent basis for FDA compliance. Excuse me if I clear my throat here a bit, but I'm in Arizona time, so I'm 2 hours behind you guys on the central US and western US and elsewhere. And also, if you have any questions, like Bill said, put them in the chat box. We're going to address them at the end of the presentation. That'd be great. So what we're going to chat about today is a fairly new ASHRAE guideline that has come out in relation to the COVID-19 epidemic. Back when the very first, I think, exposures that were quantified were back in March of this year. And literally within about 12 to 14 weeks, ASHRAE pulled together a lot of their internal engineers to develop this ASHRAE task force recommendation guideline. Those of you that know ASHRAE, they're kind of like a quasi-government agency in the sense that they do not move quickly. Usually takes ASHRAE years to catch up to developments in research for HVAC products or the environment for them to apply it as an ASHRAE guideline. I know that from my days in laboratory VAV control systems, where it took almost 10 years to get them to recognize that Phoenix Controls had a variable air volume Venturi air valve, which was far superior to a VAV box. Well, they got on the hoof and they developed this task force internally within, like I said, about 3 months. And they produced this guideline. And it's if you want to look it up, I would suggest you go to ASHRAE, just Google ASHRAE Epidemic Task Force, and that should bring you right to the section of their website. And this one we're going to be chatting about today is for schools and universities, but it really covers commercial buildings as well. And the concept here is that ASHRAE also did something quite different. They actually went out of the norm and they went outside of ASHRAE to look at what the medical field was discovering about SARS-CoV, because back in March, it wasn't really known if it was air transmitted or was it strictly by contact. Today, without question, the predominant infection spread is from transmission through the air via suspended particles from breathing, sneezing, coughing, laughing, just communicating and talking. While contact transmission is still a factor, air is equally as much the same factor. So in researching that research from a medical standpoint, ASHRAE decided that all facilities have to increase outside airflow volume, increase and record CO2, relative humidity, and temperature. And this guidance really has to be applied across all climate zones, across all schools and HVAC systems. And the reason for that is going to be quite evident in the next slide here. This, by the way, is the first cover sheet. And the reason why I'm just going to go back a little bit here, the reason why I'm steering you toward their website is because this document is over 70 megabytes, so not possible to email it. One thing that ASHRAE looked at was what are the root causes here of the spread of the infection? Number one, it's because the infection is obviously growing and maturing in our own bodies. As we exhale, we expel particulates in the guise of water vapor, small little spheres, roughly about 100 microns in size. That's what the UM means. How large is this from a relative standpoint? This is about the width of 2 human hairs side by side, okay? And the variables they looked at was temperature and pressure and humidity and how it's affected the changing of the size of these droplets, and also the time aloft, which is the number below the droplet. So as the other thing that we discovered also in medical research was that, as the humidity remains too high or too low, it greatly affects how long these droplets stay in the air. In general, if the air is too humid, these droplets do not desiccate or shrink as quickly because there's not enough latent heat capacity in the air for the air to absorb additional water vapor into it as a vapor stage. So these droplets stay larger. The plus side of that is that they fall out of the air a lot more quickly. Low humidity, these droplets tend to desiccate or decrease in size quite dramatically. And you can see the time aloft goes up exponentially. This relationship between size and time is really described by a physics law called Stokes' law. It has to do with the viscosity of the fluid that a particle is moving through, meaning the viscosity of the air. And the viscosity of the air obviously is affected by the water vapor content in the air, which increases its density, right? So step number 2 was that, okay, ASHRAE said, okay, we need to control these values. We'll talk about how CO2 comes into play in a little bit. But how do we control this is we've got to get a good parameter and handle on how the current HVAC system is working in our schools. So once we do that, we want to also collect the data after we've optimized the HVAC system to make sure that we're controlling these variables. And you do that by measuring outside airflow, measuring pressure drop across your filters, measuring the room relative humidity, CO2 temperature, and building pressurization. I think you can see now where Testo is coming into this discussion here with that last bullet point.
Hey, Steve, let me interject. You got a good question here.
Mm-hmm.
Are the guidelines, I think I know the answer, but I'd like you to give it. The guidelines a code or a requirement, or are they just simply recommendations? And how does that play out?
So good question. Let's talk about ASHRAE first, the document. I've been working to ASHRAE guidelines from their ASHRAE manuals for decades. And everything that's in an ASHRAE manual are engineering guidelines. So point in fact, when mechanical engineers design around, when they design around the capacity of a mechanical rooftop system, they look at the environmental values or weather data that's placed in the ASHRAE manual. They use that to help design the capacity of that built up unit. None of those are code, but still engineers adhere to them as design guidelines, okay? So all of ASHRAE's documents produced from day one, none of them are code requirements. Code requirements are government issued codes by county, state, maybe even city if the city is large enough. And that's where it varies from state to state. But I will say this, and we'll talk about this as we go into the monitoring and the data collection of this information. If you don't do it, there's a negative downside to this. And the negative downside is that the school or schools that are identified that are not providing these measurable variables as a monitoring collectible data to be shared could result in a litigious situation from parents notifying the school district, the principal, the town engineer, the facility engineer, the director of the mechanical maintenance for the school district. The state can be brought into lawsuits if the schools aren't doing their job of aligning themselves to these new guidelines issued by ASHRAE. So that in effect is the check and balance here of do you need to do this or not? Technically, no one's going to put you in jail, but something else may rear its head if the schools are not paying attention to these new guidelines and implementing these new guidelines down the road.
Thank you, Steve. Yeah, it can get into litigation really, and somebody can say these are the best practices. Why didn't you follow them? That kind
exactly.
of thing.
Yep. The next slide drills down a little bit deeper into this relative humidity aspect. So we're going to talk about this one measurable first. I mentioned before in the previous slide that low relative humidity causes these droplets to desiccate a lot faster. They shrink in size, albeit the viral particles are still encapsulated in some amount of H2O content and other organic matter that we exhale, sneeze or cough, or when we're speaking as a teacher, or if we're students that are sitting at our desks and we're laughing and talking to our other students across the aisleway. And one unique aspect about why low relative humidity is bad is not so much an HVAC thing, it's a anatomical body response thing, meaning that as humidity drops below 40%, the ability of our body to actually increase the production of fluid to get rid of an infection, a foreign matter, or a foreign substance actually decreases, because there's just not that much water vapor in the air to assist our body to produce this fluid. A common related occurrence is, let's say, springtime, pollen blooms. Many millions of people in the US here have allergies. What happens? Our eyes water to try to flush out our eyes to get rid of the pollen. Our noses run to eliminate the pollen trapped in our noses. We cough because we have inhaled some foreign matter in our lungs, and our lungs are irritated. Our lungs fill up with some fluid and we want to expel that foreign matter. So relative humidity has a great factor in determining our ability to combat the inhalation of anything, not just a biological like SARS or COVID-19, but other things too. Second effect is that humidity being so low, as I said in the previous slide, those droplets become very small. When they get down to the size of 5 to 2 microns, at that size, they're so light and so buoyant and so small, they tend to travel far more deeply into the lungs of human beings than anything else. And it's almost impossible to mechanically dislodge that foreign biological compound. Too high of humidity, obviously, we saw the effect in the previous slide. High humidity, these droplets do not desiccate a whole lot, which means they're going to travel farther. When the humidity is too high, I should say, the droplets are going to fall faster. Right, that's a good thing. The downside of that is that there have been medical research done on the viability of these droplets in this 50 to 100 micron size, and they actually stay viable much longer on surfaces, depending on the surface material, right? Whether it's cardboard or stainless steel or formica or plastic, and all of which you have in classrooms, that residence time or viability to cause an infection could be as much as several days. And then on top of that, you have mold growth, which is a common issue with too high of humidity. I will say that going across most school districts, I think across most commercial buildings, humidity control is the, let's call it the bastard of the HVAC industry. No one actually does proper humidity control just because of the amount of maintenance required to maintain these systems. You have to worry about contamination of the water, what you're volatilizing from that water into the airstream. Is it biologically free of contaminants, even from that reservoir that you're using? There are a whole host of issues. But the biggest issue with schools, when we looked at humidity, and this is data that was taken by the Department of Education, a division called the National Center for Education Statistics. Back in 2014, they discovered that after surveying about 100,000 schools, today there's 130,000 schools in the US, K through 12. And these are just public schools, not including private, okay? Average age is 42 years old. I was in, where was I? Last week, no, 2 weeks ago, I was back on the East Coast of North Carolina and went to a school district right outside of Raleigh-Durham. Saw 3 schools. All 3 were 50 to 60 years old. So guaranteed, what they found in this research data back in 2014 is that they did a survey. They actually polled the administrators across 2,000 administrators, over 300 schools. And they found that most of the HVAC systems were rated as being fair to poor by the administrators. And they noted that most of the windows were inoperable, were purposefully sealed for security reasons. which have big ramifications for how much outdoor air we bring in. And why is outdoor air an issue? Well, back in my days in college, when I was taking chemistry class, a common term in the chemical industry is, the solution to pollution is dilution, right? So if you can dilute a 50% normal container of hydrochloric acid with 100% water, you're going to decrease that solution by half of its strength. So the same thing here with airflow. If we can bring in more fresh outdoor airflow, which by volume has proportionally a lot less potential suspended COVID in the air compared to the inside air in the space, we're going to decrease the probability of transmittance of COVID. But if you have minimal or zero outdoor airflow, that's a problem in elevating the risk of spreading the infection. The other thing that they found out back in 2012 and 2015, these two studies, one done by Lawrence Berkeley Laboratories, which is a lot of people think it's a university lab. It is and it isn't. Kind of like JPL. It's administered and run by Cal Berkeley, but it's a government lab facility, just like Sandia Laboratories or Los Alamos. And they went across several hundred schools and actually looked at cognitive performance in CO2 buildup. What they found out was that most schools' carbon dioxide content, again, because of these closed and sealed classroom conditions, mostly in the fall and winter months, which is when most of the school year occurs, carbon dioxide would normally peak well above 2,000 parts per million, even as high as 3,000 parts per million. Just to give you a relative indication, outside CO2, outside ambient air is about 400 parts per million. But they found that there was a cognitive decline with these high CO2 values. But they really didn't have a double-blind study to quantify that. Well, roll forward 3 years to 2015 and 2016, Harvard did do a cognitive study that was a double-blind study with the Association of Syracuse University and Carrier Corporation underwrote the study. And what they found out was that if they started off a closed building space with about 1,100 parts per million of CO2, which is ASHRAE's standard value in the ASHRAE 62.1 guideline, and then they dropped that CO2 by half down to about 650, there was an associated cognitive increase of over 62% across three main cognitive variables they actually monitored. How did they quantify this? Well, Harvard actually employed 9 neurologists to actually come up with a test for these 24 office volunteers that worked in this research environment where they varied the CO2, but they weren't told that the CO2 is being varied. And it was shown that in the cognitive functioning of the test, that when cognitive scores increased, CO2 decreased. And when cognitive scores decreased, CO2 increased. So there was an inverse direct relationship to this. Then they actually went out in 2016 and actually quantified that by going and looking at 10 different commercial buildings in 10 different areas of the US. And they did the study for 3 months. And what they found was that over 3 months, the absenteeism rate or time off rate requests to HR from these 10 different businesses, 10 different commercial buildings actually decreased enough that they saw a quantifiable gain in productivity in less lost time by their workers. So not only do you get a benefit of with outside airflow of decreasing the probability of spread of the virus, the secondary benefit is you're going to get a cognitive increase in the performance of students because the CO2 has been decreased. Wrapping this up with more current studies, this is just a couple of months ago. So now, today, and the reason why ASHRAE put CO2 in as an important component to be measured in the guideline was because that now that the established relationship between CO2 and risk of infection is linked, is now considered to be a co-surrogate to COVID-19 or a risk proxy, meaning that you have an infection risk proxy increase with high CO2 numbers. So, and when you think about it, we exhale 3 things. We exhale CO2, we exhale water vapor, and we exhale viral particles. and they're all encapsulated in these little droplets. So bring in more fresh outdoor air, you're going to solve a lot of problems here. To kind of wrap up ASHRAE's 42-page document, I try to condense this down into one slide. It's kind of difficult, but number one, the first thing that ASHRAE wants all schools to do, and this is elementary schools, middle schools, high schools, community colleges, and universities, is re-baseline the performance of your current HVAC system. You know, maybe your building was built 5 years ago, maybe it was built 15 years ago, or 25 years ago. But back when it was built, there was some design mechanical performance envelope that was created by the mechanical engineers to initially commission the building. So they want all schools to go back and remeasure all those values, compare them against how the building was designed, and see how far off you are. So in other words, before you start controlling this stuff, you've got to get the basics right. And to do that, we've got obviously Testo instrumentation to assist in measuring all these common variables that we speak about here. Next, once you've baselined and established that your system is working pretty close to the original specification, you want to change your building sequence. What does that mean? That means before school starts, or before, let's say, a commercial building is occupied, purge that facility for 2 hours. What does purge mean? It means go to max exhaust, max supply, and maximum outdoor airflow for 2 hours. And then when classes or school ends, or when work ends in that commercial building at the end of the day, do the same thing on the back end, purge it for 2 hours. Next up is control CO2 and measure it to a maximum of not to exceed 800 parts per million. The ASHRAE document states 800 to 1,000. Again, being those are maximal values, I would err on the lower of those two ranges. I would say 800 would be a target, not to exceed. And that's really related to how much, again, fresh outdoor airflow you're bringing in schools, because of, we want to increase this outdoor airflow in the major congregating areas where there's going to be a lot of human beings in a confined space. So classrooms, classroom laboratories, hallways, a minimum of 10 CFM per person. And when you go into the larger venues on a campus, like sports gyms, sporting arenas, weight training rooms, cafeterias for lunch and for morning break, all areas where you're going to have a large congregation of people, double that minimum outside airflow to a minimum of 20 CFM per person. And then depending upon where you are in North America, minimum of 40, a high of 60% RH, depending on the season and your geography of where you're located, and generally 72 to 75 degrees Fahrenheit average temperature in the space. This is a big one, increased filtration, and I'm going to step out of this presentation for a second and talk about why MERV 13, because that's been a common question when I give a lot of these classes. And then install relative humidity, CO2, and temperature monitoring sensors. And we'll talk about what type of sensors to use. And again, measure these variables in the occupied rooms on a 24-hour basis. And then the nursing room or the nurse's location has specific criteria now as well to control to. And then at the end of the day, we need to data log, capture that data, and share that among the district committee. What is a district committee, you may ask? A district committee is, let's go to, I think I'll find this pretty quickly here. So, all right. So this is actually,
I'll just say this is really cool stuff because Steve is actually hands-on with this kind of work. So you're getting information, I don't want to call it the horse's mouth, but you're getting it directly from someone involved in this.
Somebody's mouth, I guess. So this is the actual document here. So actually on page 1, 2, 3, page 3 of the ASHRAE guideline, the very first thing they talk about is to create this district committee. And what this means is that it's going to be made up of typically, who are the stakeholders in a school district? They are the, if a school district is big enough, they might have their own EH&S person, environmental health and safety person. Administration, that means vice principal, principal of the school, educational staff, the leaders, the teachers in the school, operations, that is facilities, local healthcare providers, et cetera, would be also parent-teacher groups. Parent-teacher groups or PTOs or PTAs are very, very powerful in relation to what they want and what they need to have in schools, because it's all about the kids' safety, right? And I'm going to go to the next slide. This is page 3 of the ASHRAE document. I'm going to go over to page 5. And page 5 here is the specific recommendation for temperature range and min and max relative humidity range, and then the requirement to trend and monitor those 2 variables in each space, either with a BAS system or data logging technology. Okay. And the next page, on page 6, talks about the same thing, but doing it with CO2 sensors, measuring those variables not to exceed between 800 to 1,000 ppm, and a trend and monitor on a continuous basis as well. So that's where the rubber meets the road, everybody. So let's go back into the PowerPoint here. And last thing we'll chat about is the nurses location, because it's now going to be treated as an ASHRAE 170 guideline, and this is actually the spec on how to engineer mechanically an isolation room. So we are converting a nurse's office to literally a hospital grade level isolation suite. Because what happens? Well, a student walks down the hallway, complains of a headache or fever, sees the school nurse. Nurse may, after looking at symptoms, may administer a COVID-19 test. Takes a while for those results to develop. So the nurse will probably move that student over to an isolation or quiet room, which you can see here is to be negatively pressurized, or having a negative pressure around relation to the surrounding spaces by, minus 0.5 to minus 0.015 negative. And then because the nurse may have been affected as well, we can't let her breath escape to the common corridor space or other class spaces. So this too will be kept negative. And then the next step that the nurse might take is call the parents, right? The parents are coming in from outside. They probably are not infected, but we want to keep it that way. So they should be going into a separate room that is positively pressurized, so the net airflow is moving out of any doors or any slots under the door to keep the parents safe. And ASHRAE went to such an extent to actually specifically state that this system has to be its dedicated own HVAC system for this area. Okay, so now you can see once again the need for measuring pressurization differential in all these spaces. Testo has the equipment to do that, but there is a whole HVAC upgrade here. You've got exhaust fans, new supply fans, interlocked basic controls, because you have to have 2 switchable modes of operation between isolation and normal mode being unoccupied, no student in this infected area, and the nurse is just at her desk. It's got to be 100% supply and exhaust, just like a laboratory building with 10 air changes per hour. And you've got to have at least a MERV 14 filter if it can't support a HEPA filtration system, or a MERV 7 with HEPA. Okay. So going back to the baselining of the HVAC system, when we talked about the need to measure supply flow, exhaust flow in each room space, building pressurization, pressure drop across all filters, temperature and relative humidity control, and also CO2 monitoring in each space, that really has to be done by a number of instruments. Luckily, Testo has the Testo 400, and the 400 is called the IAQ 400 for a reason. We've got the ability to connect up to as many as 4 wireless Bluetooth probes. So you can envision, here's a Testo probe stand on this little tripod stand here. And you can actually affix as many as 1, 2, 3, 4, 5, 6 wired or wireless probes on the stand, and take your measurements throughout the course of a day. The cool thing about the 400 is I can have 4 wireless Bluetooth probes, one for temperature, pressure, relative humidity, and CO2. And I can actually have a separate IAQ data logger, which looks like this device here, but with no display. This little cable attaches to the bottom of the 400, and we will actually tell this data logger when to start taking the readings, what would be the sample testing frequency in time interval for each sampling measurement. So we might say, let's start this at 8 a.m. in the morning, and I want to measure all 4 of these variables every 15 minutes. And after 8 hours, or let's say 3 or 4 p.m., let's end the testing procedure. And I unplug this, and I might go to a second room and set up the same test there with another data logger. So I can actually program all these data loggers, and once I disconnect it, it's going to run and do its thing all by itself. While you can take this unit up to the mechanical penthouse or the supply and exhaust flow areas of the main mechanical system, do your duct traverses, measure your pressure drop across the filter assembly, measure the external static pressure at the air handler, all the variables that are needed and actually done at the beginning when the system was designed and installed. Another cool aspect is that the 400 has a number of ASHRAE protocols already built into it. One of the easiest ones, and it's hard to see here, but you see this square grid here and a number of dots. Well, that's the ASHRAE 111 protocol. That is a really simple thing whereby the unit will say, okay, so you want to employ ASHRAE 111. How big in length and height is the duct that you're going to measure? Is it square? Is it rectangular? Is it oval? Or is it round? And you pick one of those 4. And once you input the lengths and width of the duct run and the size of the duct, it's going to come back and tell you how many measurements you need to take across that traverse, so you know how far to insert your probe in any given duct. And once you complete one reading, it's going to give you a checkbox and show you that you got to take another one. So it's really quite simple. So at the end of the day, you can actually collect all this data. I come back at 4 o'clock, I download the data from the data logger into the IAQ 400. And then the IAQ 400 can email out a PDF report, either an Excel spreadsheet format or a CSV format, which is the same kind of thing, or a JavaScript file. And I can actually email that to the administration, put the school's logo or mascot on there with the company address, the name of your business, or the group that actually did the testing. And you can actually image and photograph the measuring location to prove that you actually did the measurement. You can attach that or tag it with the data from that room. So really neat device. This is all about baselining, right? So once we've baselined it, the question is, okay, going forward, what do we do about monitoring? And remember back on the one of the very first slides, ASHRAE said that you can actually use a BAS system or data logger instrumentation. Without a doubt, you can do that. And some newer schools may have a BMS or a BAS system. What that acronym means, it means Building Management System. BAS is Building Automation System. They both mean the same thing. It's pretty much the nervous network that is supplied by these big temperature control contractors, Siemens, Johnson Controls, Honeywell, and others. And they do a great job, right? They do amazing stuff like, measure and control and monitor the fire detection and alarm system, measure and monitor and data log security and access controls. They measure and monitor CCTV output for burglary or break-ins. They will monitor and control lighting controls throughout the course of the building. You might have light sensors on the east side of the building, on the west side of the building. The system will sequence these building lights to go off with the morning sun coming in, turn them on if the sun's on the west side and vice versa. And also, they will take in temperature sensor inputs from each room, all right, to control a VAV box to bring in supply air, to control reheat coils, to bring in warm air in the wintertime. But the problem is, two problems, is that the BMS system and their sensors are not data loggers. They're designed to measure and send an output to a control device like a fan, a variable speed drive. Something's going to change something to keep the environment conditions constant. And even if they did have data logging capabilities, which they do not, the ability or the accuracy and the range of those sensors are really, even though supplied by commercial contractors, they're below commercial grade, meaning that they're bought on a lowest bid proposal, right? On the device side, without question, some of our competitors like at TSI and Fieldpiece and others have handheld instrumentation that can measure these same variables that we're talking about. But when ASHRAE talks about measuring this data on a continuous basis, that means these are going to be installed permanently. Okay, so I don't know of any of our handheld instrument manufacturers that have a permanent solution to install and monitor and data log these critical variables. And at the end of the day, the important thing is that you really want to separate the collection and the validation of these environmental values from the system that's providing the control. Might sound counterintuitive, but it's kind of like the fox guarding the hen house. And me being, working in the building automation system business for quite a while, one of the things a BMS system gives a user is the ability to filter the display on a temperature wall-mounted unit. So meaning that I can actually display a nice consistent number, making people think in the building that the system is working fine. I can actually change and smooth out the output of those measured variables to the building system because they use a program, actually it's calculus, called PID control, proportional, integral, and derivative control. And depending on how you vary those 3 points, you can actually smooth out the output and smooth out the response of the system to show that it looks really stable, meaning that the system is working great. You don't want to do that when it's a life, health, and safety application like ASHRAE is identified here. So what's the solution? So Testo, going back, remember back in the original, one of the very first slides, I had this slide here that showed, that we provide, data and technology for the life science and the food safety business. Well, about 6 months ago, I was, trying to utilize new products for the HVAC side here. And then COVID hit, and I discovered that on this side of our business, we actually had a system called the Testo 160. And the Testo 160, if a BMS system is a classic wired system, meaning that I've got a temperature sensor in this room, and I've got a wire coming out the back of it going to some network control module in the interstitial space in a building, and you'll have a wire coming back from each room, right? Bringing back an analog input value of what the temperature is in that space, and whether that sensor is saying, hey, it's 72 in here, but I need to be at 75, it's winter. I need a heating command for this room, right? So every single room has a wire coming out of it for temperature output, right? And then when you go to that network node here, it's collecting all the sensors from that floor, and you'll have nodes on each floor which collect data from all the other rooms, and that goes up to another controller. You get my drift here, right? And then each of these temperature sensors have to be power wired, okay? They don't run on batteries. They run on 24 volts AC, 24 volts. So when we look at the Testo solution, 2 important things. Number 1, it is battery powered. Number 2, it is Wi-Fi encrypted, okay? So wireless power, wireless transmittance of data, all right? And not just that, but our single unit here has the ability to measure all 4 of these variables of CO2, temperature, humidity, and pressure, and also has the ability to store the data in the unit and or send it out remotely, okay? When we look at the number of devices that we have here, the one we're predominantly talking about is the Testo 160 IAQ today. We also have the Testo 160E. We'll chat about that in a second. But the 160 IAQ, you would basically put 1 in every room. You might employ 2 in larger spaces like a cafeteria. We can talk about where the proper space or location is to mount these, but I would say classrooms, you want these above reachable levels for kids so that they don't tamper or play with anything on the unit. And it's really good practice to locate these pretty close to where the return air is in a room space. So you're getting a good sampling of the total CO2, the total average temperature, and humidity in that space. Excuse me. And then in a cafeteria, I would, again, one by the return and maybe one more centrally located across and away from the major transition areas. Let's say not near any doors that go to other zones, but you want to have one in a kind of a quiet area and one near the return. And the benefit here again is that it's Wi-Fi based. It's encrypted, and it's got to be encrypted because remember we're using this system in a application like food and pharma. Food pharma is really controlled by FDA guidelines, and FDA guidelines have a acronym called CGMP. So the C means clean, G means good, M means manufacturing, P means practices. So clean, good manufacturing practices. So every facility that makes anything that is consumed by a human being, whether it's food, packaged food, fresh food, or whether it's pharmaceuticals, aspirin, antibiotics, Benadryl, if we consume it, FDA mandates that that facility must monitor the environmental conditions 24/7 while they're in production. Some of you that are old enough remember back maybe about 15, 20 years ago when they had that Tylenol scare, when there was word that a disgruntled worker might have tainted a run of Tylenol. Well, the FDA came in, shut down that facility, and the FDA then said, okay, give us all your data. They pulled all the manufacturing data, they pulled all the environmental data, and that's what the FDA does. So every facility that makes food or medicines must use this kind of monitoring system. Well, here we are in the day of COVID, and the same variables that they're monitoring over there, we now need to keep track of, right? And the 160 has the same capabilities almost as the IAQ 400, whereby we can actually output PDF or CSV reports. We've got the ability to provide upper and lower alarm limits, either via text messaging or via email, okay? You can do that as well in a building automation system. It's gonna cost you a lot more, and we'll talk about that here in our next slide. So what I did here was I took a couple of examples. Number one, I went to the internet and I looked at today's currently available products from Siemens, from Honeywell, from Johnson Controls. Both Siemens and Johnson Controls have units that also measure these three variables: temperature, pressure, relative humidity. Sorry, temperature, relative humidity, and CO2. Honeywell has a unit that only does humidity and temperature. Does CO2 and temperature, but not relative humidity. So that you would need a second module here. And these prices are current internet pricing. This is our current street retail list price. So we're very competitively priced against these guys. But the important thing here is I just took 20 classrooms and knowing that we've got to monitor these three variables, right? So that means we're monitoring 60 points of data. So 3 times 20 is 60. And if you're a building system contractor, the way you calculate how to provide a price to a school is you take the number of points and you take a cost to implement each point, and that cost on average is between $1,500 to almost $2,000 per point. Why is it so expensive? Well, the reason being is that temperature control contractors, they've got to basically schedule this new feature or number of features to be measured. They've got to program it. They've got to engineer it. They've got to configure it into their system. They've got to install it. They've got to start it up and commission it, okay? And this is excluding the cost of each of the devices themselves. So this is strictly all labor. So when you take 60 times this number, you're getting a number that quickly approaches 100 grand in the US dollars for a small application like 20 classrooms. By comparison, if you know how to go to Lowe's or Home Depot and buy, let's say, a very inexpensive battery-powered Wi-Fi thermostat, and you take it home and you put the batteries in it, you connect it to your Wi-Fi router in your house, you create a password for it. That is the commissioning installation process for Testo. That's it. So what I took here for labor was I just took 1 man hour per unit times an average cost of about $150 of field time technician cost times 20 units, gets us to about $3,000 US. And then just multiplied close to the list price times 20 units. So if we combine these two numbers, we're 1/5 to 1/6 the price of a BMS contractor installing the system. And then on the accuracy side, one thing that's important to note that is the CO2 range of coverage of our unit is 0 to 5,000 parts per million. Remember when I said back here that most schools actually peak above 2,000, even 3,000 parts per million? That doesn't help you when the sensors provided by the big three stop measuring at 2,000 parts per million. They can't even go past that. Well, that's right in our sweet spot, being that we measure from 0 to 5,000. And the other cool thing is that we can actually have our probes, the 160, NIST certified even before they're installed. So that way, the burden of proof to prove that the data that we're outputting is 100% reliable, we've got that proof statement with each system, with each unit that we go into each classroom. Can you do that with a building automation sensor? Yeah, you could. It's going to probably cost you 3 to 5 times the amount, because Testo is one of the few companies that have our own NIST traceable certified laboratory here in the US, and we can actually NIST certify any probe that we sell. Okay, so this is a very quick going over of the guidelines and how Testo can help you not only baseline the performance of the HVAC system at any school, college, or university, or any commercial building for that matter, but also how to provide a complete permanent solution installed. And one thing I forgot to mention, it's really easy to put in a test system in a school. The school buys 1 or 2 of these. And because each of these units has an internal data memory storage capacity of up to about 3 months, you don't even have to have our cloud service enacted to have this test system run. This little plug on the bottom here, you can actually unplug it. There's a micro USB-C port here to connect the cable to, which is provided with the unit, and it's a USB on the other end, so you can actually have your laptop. You actually pull your data down from the day during your test period, right with a laptop, and not have to worry about even getting it out to the cloud to have it monitored and controlled, or measured, I should say. That concludes the PowerPoint. Here's my contact information on the left. And Bill, you might want to say something again about TruTech and how to access the products, and any other questions that anybody has. I'm here for the next 30 minutes or longer. I'm yours. So.
Okay. Thank you, Steve. This is, I'm sure, illuminating for all. I've seen this a couple times, but I keep on picking up new information every time I review it. So it's really dense with information, but Steve does a great job in presenting that. We did get a question a little while ago about MERV 13 filtration, and I'll just kind of read you the question verbatim because he brings up a really good concern. Todd does here. With MERV 13, it can kill airflow, as we know. Not all buildings are set up to energy code. And he's talking from the state of California, Title 24, because there's older buildings, very old campus, I believe he works at. So adding MERV 13 destroys airflow and can destroy equipment and therefore manufacturer warranty. What are the recommendations in a case like this, even after the baseline as described?
Okay. So I'm trying to find, let's see, here we go. Yeah, so this chart here. So let's look at why they're saying MERV 13, number 1, and then it'll become clearer as to why you really need to strive for that. So what we're trying to do, number 1, is to capture as many of these suspended particles as they decrease in size in a classroom, right? So one interesting thing that was brought out to me, and I did not even realize this, and I've been in the filtration business from a biological standpoint for a long time. But what I didn't really know was that the ability of any MERV filter from a simple MERV 1, which is not that far above, a standard residential cheap house filter, all the way up to a MERV 12, they all have the same maximum capture ability of up to, but not exceeding 20% of particles of this size. And to me, that's pretty astounding that a MERV 1 and a MERV 12, there's literally no difference at this critical capture size to collect as many of these suspended air particles that have, viable viral particles inside these droplets. Okay. Even though the COVID virus is actually only 0.125 microns, it's got to be in some liquid envelope to keep it viable. So even at this size, even if it's quite a bit larger than a HEPA filter pore size, which is 0.3 microns, from 0.3 to 1, a MERV 1 does as good as a MERV 12. So why pay for a MERV 12? But you see there's a great big jump when you go from 12 to 13. Okay. An amazing jump by a factor of threefold in its ability to capture. And that's the whole game here, is what can we do in the best possible practices to achieve these numbers. And so that's why MERV 13 is mentioned. And a MERV 13 filter does not cost that much more than a MERV 4 filter. This is a study that was done back in 2013. I went online to check prices, and they're still about the same range, but there's maybe a $20, $30, $40 price difference between a 13 MERV and a MERV 4. But when you look at the actual fan power cost, and this is what I think what the question was getting to about, it's going to destroy our systems, it's going to cost too much, the pressure drop's too great. Today's MERV 13 filters, you can buy a number of MERV 13 filters that require a less than a 0.2 inch pressure drop across it. As a matter of fact, some are down to 0.16 inches. Okay. And the only thing that you want to do when you put in a MERV 13 filter is you need to just check it more often, obviously, because you're going to have either a 2 or 4, maybe even a box filter, depending upon the ability of your system. But this is the reason why ASHRAE states that let's go back and baseline test the system, because every mechanical system has a min and max pressure drop capability for on the suction side to accommodate filter and filter loading. So I would not assume that today's MERV 13 filters are going to be a big problem, especially from a performance standpoint or reliability standpoint for the mechanical system, because their engineering is getting better. The pressure drops are lower, and you just might have more frequent changes of a MERV 13 than what you did before COVID. And remember, these values or the need to use MERV 13 are guidelines only for when a pandemic state exists. Okay, so when a pandemic is deemed to be over, you don't need to use MERV 13 filters. Okay, so it is a temporary situation.
And Steve, I want to interject a couple things and maybe have just a little dialogue on this point. But one point is something I became aware of in the last few months is a filter is not a sieve. There are like 4 different modes on which a filter works. So there's forces in there. There's Brownian motion. There's all kinds of things the way a filter works. So that's an important thing to recognize. Filters aren't just straightforward like a sieve, like a spaghetti filter kind of thing. The other point I want to make is, and get your reflection on this, is a lot of systems are designed to have a heating and cooling filter for space conditioning, but we're now talking about a new mode of ventilation filtration for health and safety. And the system might not be designed for it. That goes back to your point of being designed to do this. And perhaps something like bypass filtration or taking a slipstream of the air and running it through this higher filter just for the sake of filtration only might require redesign. What's your thought on that?
Well, again, there are just looking at the age of all the schools that are out there, I've seen schools that have been built in the past couple of years and then schools that have been built 60 years ago. And what ASHRAE is saying is, strive to put in a MERV 13 filter if you can. Okay. If you cannot, okay, you've got to do what the system is allowed to give you. All right. And I will say this also is that many school districts have seen this coming. I know school districts in California, some of them actually have passed taxable bond issues with the last election to pay for HVAC upgrades like this. The three biggest school districts in Florida, Duval County, Hillsborough County, and Brevard, have all passed the same measures in the last election that they've, to pay for hundreds of millions of dollars of HVAC upgrades, again, to get the schools up to this new guideline. So that is actually happening today. The other thing too is that the ASHRAE guideline realize this, and they also state that if you absolutely cannot put in a MERV 13 filter, well, then you need to go out and purchase individual portable HEPA filter units and place them in the classrooms. Number one.
There you go.
Same thing. If you can't afford to put in a brand new systemic relative humidity control system, depending upon your location, whether you're in the southeast or the southwest, we deal with lack of humidity. So you must put in a humidifier portable system in each classroom to keep the humidity constant. Southeast, you want to put in dehumidification portable units in each classroom if you cannot accommodate it in your current HVAC system.
Very good. And we did have another question here, and I should have asked you this beforehand. We are recording this, so we'll go on the TruTech YouTube channel and on our site, and we will send the recording link to anyone who registered. Would you be willing to share the slides in any format, PowerPoint or PDF?
Oh yeah, sure. That's
Okay.
not a problem at all. Yeah.
Very good.
Any one slide through the entire presentation, that's not a problem.
Very good.
Yeah.
Okay. I think that takes care of the questions we've received up to now. Really want to thank you for your time here. And Steve's a very dedicated worker on this. And like I said, it's real fun to work with him. I love his mind, the way he thinks, and sort of the solutions that he presents for us. So presents to us, and then we present to the customers like we are today. So again, TruTech Tools is a large reseller of Testo products. We might have not left the Testo 160. It might be a little hard to find on the site. We're going to fix that today. We did get that feedback already from someone. Larry, thank you for pointing that out. And we'll get all these things going and in line. I want to thank everyone for listening today. And thank you, Steve, for your presentation. And you can always reach us at info@trutech.tools.com or calling our phone number, 888-224-3437. And yeah, we will, there you go, Leon, that's Steve's contact info, Pascuzzo@testo.com and
Right.
info@trutech.tools.com. And the web link for the presentation will be emailed to everybody that registered. So it'll come back to the email address that you registered for. You'll get a link to the video once we put it up and process it. And also, I wanted to mention that we will be having a second event in January. We'll have registration details for that. Steve's going to take a little bit deeper dive sort of into the mechanics of setting up this equipment to do data logging and monitoring, give us some example screens of what the data looks like. So this is introductory, and the next one in January will be a little bit deeper dive into that. So we hope you will join us again in January